Well, hey, we're back and check it out. We're doing more math things. Yes, math. It's math. What? Yeah. Hey, welcome back. Expressions as rules. We are continuing to do so many amazing things around math. Um, Lately we've been handling this whole algebra thing. We've been talking about substitution. We've been talking about PEMDAS. Um, we've been talking about expressions, equations, number sentences. And today, what we're going to be looking at is this concept of expressions as rules. The reality is these expressions are all kind of rules, but so it's no different. It's just like, how do we identify them and then state like, what is this rule based on a set of data or information? Um, so that's what we're going to do today. So again, remember, if we're talking about an expression, we're talking about, well, first, actually, let's do this. First, let's do a number sentence, right? So if we had a number sentence, right, just like a sentence in a book, it's kind of consists of everything. So like a number sentence could be like 3 times 7 equals 21, right? That's a number sentence, although I don't know if that's really a good multiplication symbol there. Let's use the dot. I don't use that one enough. So 3 times 7 is 21, right? That's a number sentence. It has numbers, it has operations, it has equal sign, it has a solution or an answer. So that would be a number sentence. So then the next stage of that is like, well, what happens if we take something away from there? What if we say 3 times A equals 21 and we need to figure out what A is? Well, we call that the equation, right? And the only piece to that then with the equation is that we have a variable. So we have numbers, we have multiplication, we have an equal sign, or sometimes that could also just be greater than, less than, or equal to, right? Those are still equalities. And that would be the equation. Now, when we get all the way down to the expression, the reality is we're literally just have these components, 3 times A. That's it. And we may need to substitute to figure that out when someone tells us what A is. Another way we could show an expression could just be like 2 plus 3. That's also just an expression. So again, there's no equal sign or greater than or less than. So there's no equality. And there's also no solution written yet. And we'll find them, right? That's what we do. That's the math in it. That's how we evaluate, right? That fancy word for solve, evaluate. That's how we do that. So anyway, those are expressions. Today we're going to talk about like what happens when we see a set of data and we can identify like what is the rule that's happening. So now that I've babbled for a minute straight, let's go ahead and just talk about what this means. So often we'll see two forms of what could be considered a data table. We may see like a T-chart, right? Where we may have something like, what if we had here feet, and over here we had inches, right? We could also have a data table that maybe looks this way. And it could be something along the lines of like, I don't know, a set of data of something. Let's hear, what's our set of data? How about this is the number of test questions. We did just get done working on those standardized tests. And then the number of test questions is, it relates to maybe the number that is multiple choice, right? So I'll fill this in so it makes more sense. I was just trying to build something. So for example, right? So let's go back over to this one. Again, if we know we have 1 foot, maybe we have 12 inches. And if we have 2 feet, we're going to have 24 inches. And if we have 3 feet, you know, we're going to have 36 inches. And then it might be, oh, well, how many feet's in 48 inches? Okay, so there's a few things. One, we got to understand what is the rule here. What is the rule that's being stated? So that comes down to the expression. What is happening here? And one way I can really start to look at that is I start with information I have. And what I see is that I start with the number 1, I end with the number 12, right? If I have 1 foot, I have 12 inches. So my first thing that my brain's saying to me is, oh, well, if I start at 1 and get to 12, well, I'm getting bigger. And in math, we know that there are two operations that help me get larger values. One would be addition, one would be multiplication. So if I think about that, again, I have 1, I'm getting to 12. Well, there's a couple things. It could be that if I take the number of feet, and in this case, I add 11, I'll get the number of inches, right? Because 1 plus 11 equals 12, right? This is substitution. So if that's the case, then I want to apply that same rule. So then what I'm saying that rule is that I'm saying it's plus 11, right? So, and again, if we want that expression, it's going to be feet plus 11. So let's look at that. Well, that means then F is 2. So 2 plus 11 is 13. But that's not what this says. So that actually is wrong. That's wrong. It doesn't work. It doesn't work. I can't have this rule that I plus 11 every time. So maybe what I've just learned from that is that adding it is not going to help. So let's think multiplication. So again, start thinking. If I'm at 1 and I multiply by a number, I get to 12. Well, that actually would be 12, which means now I could think about a rule. A rule might be that I have F times 12, right? If I put in 1 for F and I times it by 12, I'm going to get inches. I'm going to get my answer inches, and we could test that out, right? Okay, in this case, F here for this one, F is 2. So I'm going to put 2 in place of F, and that would be 24. And that is what I get there. Okay. But also let's try other ones. So now I have 3. So if I say 3 times 12, well, that's 36. And guess what? That is it. So here's my rule. My rule does make sense. My rule, my expression here in this set of data is that if I take F and I multiply it by 12, I'm gonna get inches, or I, if you will, if you need a variable in there. So now that I know that, I got to think here, how do I find this last point of data? So my rule is F times 12 is equal to I for inches. So to help me solve that now, I want to look over here and I'm going to substitute. Well, I actually don't know F, so I'm not substituting F. I'm going to keep it the same. My rule is the same, times 12, and I do know I. It is actually 48. So I'm going to take care of this I. I'm going to substitute and put in 48. So something times 12 equals 48. Well, if I don't know that, I can use the inverse and say 48 divided by 12 equals what? Or equals F. And I see that in this case, that would be 4. Okay, so that's what this work is all about. You're going to have a particular set of data. First, you kind of want to find what's your expression, what's your rule, what's the rule that's happening here. And then you're going to use that to help you solve. So let's go to this other example here. I'm going to erase this because we'll probably need some workspace. And let's fill this in with something. I don't know what we're going to fill. Let's see. Maybe if there's 20 test questions, 10 of them are multiple choice. If there's 30, then it's 20, it's 40, and it's 30. And if there's 50, well, we don't know. Okay, so again, we're looking at this concept of comparing data. Well, I'm going to go back to thinking about how do I find my rule for this particular, or my expression for this set of data. Well, I know that here, if I start here and I go here, I get smaller. I'm at 20, I got to 10, right? I put in 20, 10 came out. The next time I put in 30, 20 came out. So each time I do this, I'm getting smaller. In math, then we also know that there are two operations to get me smaller: subtraction and division. So what is happening every time? What is consistently happening every time is the expression. And maybe I'm going to call this T for test and this for multiple choice, right? I'm just giving myself some variables to help me think about that. So my rule, it looks like here I have T, and then am I subtracting something? Well, okay, well, let's just see. Let's say we subtract something. T subtracting something equals M. All right, well, in this case, this T is a 20. And I still don't know what I'm subtracting, but when I'm done, I get 10. See how I'm just substituting to help me think about that? So this is my not sure. And if I had 20 and I subtracted something to get, oh, I have to take away 10. Right, that would actually be my rule. So this would be minus 10. 20 minus 10 equals 10. So that checks for this. So what my rule then is, what the constant is I'm always subtracting 10. So I'm going to rewrite that as my expression. My expression is going to be T minus 10. So if I take T and I take 10 away, I'm going to get M. And again, I just made T. I made up those variables myself in case you're wondering. I could call that S, W, X, Y, Z, M, W, 4, not 4, sorry. Don't use a number. That'd be confusing. So my rule at this point is I'm taking 10 and I just want to test this, right? If we think about the steps, we want to find the rule. But in order to make sure we know the rule, we want to test it and then we'll solve. And so again, I'm going to go and test this to see if it works with all of them. So man, I need a bigger screen, all this, right? And this is the cool thing. The end of the year, the more work we do, it takes up more space and that's totally fine. So my rule is T minus 10. In this case, T is 30. So if I follow that rule of 30 minus 10 is 20, then my answer in M should be 20. And it is. So, okay, the rule works for here. I'd say test it at least 3 times. Don't just test it twice. You never know. So let's do it again. So I have this time 40 is T, subtracting 10 gets me 30. 40, check. 30, check. Okay, so this works. So I know my rule. My rule is T minus 30. That's my, or minus 10, excuse me. That's my expression. So let's do this last one to help myself solve it. It's T minus 10 equals M. What do I know about this particular set of data? Well, I know my T is 50. So I'll substitute. I know minus 10, that's the constant rule. That hasn't changed the whole time. And then I need to get to my M, and what this M is going to equal then is 40. And that would be my answer in here. So we're still using all the same skills we already know: substitution, order operations, right? Understanding the values of these operations, how things get larger or smaller in value based on the operations, as well as understanding expressions and then testing them and applying them. So let's play with another one. Let's kind of go with this and we'll wrap it up after this. I think 2, 3 will be a good example. So let's look at another page and I don't know, let's make up a table. Oh, I know, here. You might also see it this way. So let's do it this way. This is another way. Sometimes they kind of give it to you. They're pretty nice like that. Like this. Let's see here. We'll call this X. Go, what's our rule? And actually down here is X, I'm gonna say minus something. So we already know we're subtracting. We don't have to look for it. And let's, I don't know, fill in 18 and 5, 21 and 8, and 26 and 13. So in this case, we're really just looking for the expression. And we have all of our data, but what we have to do is realize that what it's saying here is that we have X minus something, and that's going to equal this piece, which I'm going to help me with the equation, I'm just going to call this Y for now. So that's what we need. And let's just plug in what we know. Let's substitute, right? Substitute. So for the first one, I'm going to take 18. I'm going to put it in place of X. So let's erase the X. Put 18 in here. I still don't know what this is, but I do know when I'm done with it, I'm going to have a 5. So 18 minus something equals 5. Which if I find 18 actually minus 5, I'm going to get the same difference, and that is 13. right? So right now, what it looks like is my rule is x minus 13. I take 13 away from x and I'll get the other value. So let's test that. Makes sense for now, but let's test it up here. So again, x minus 13 is equal to y. And here's my x and here's my y. So I'm going to substitute. So in place of this x, we're going to put in 21. And then the y would be 8. Right? It already tells me that. Oops, I didn't mean to erase that. I was actually trying to highlight that. It already tells me it's 8. So we go 8 here. And then we just see, is that a true statement? 21 minus 13 is 8. That is true. So this checks off. So my rule does check off. It does work. And I can even see it up here. It says 26 minus 13 equals 13. And that is a true statement. Okay, so that's kind of the stuff you're dealing with here. It's just like paying attention to these data tables and thinking about what is the rule? What do I notice? Again, I would always state that if that doesn't tell me, this one was cool, they actually do tell me. But if it doesn't state here, right, like over in this one, it doesn't say we're adding or subtracting or we're multiplying or dividing, then start with what you know and ask yourself, hey, am I getting larger or smaller? If I'm getting larger, then I'm multiplying or I'm adding. So test out a few theories. If I'm getting smaller, right, which I did in this case, well, then I'm either dividing or subtracting. So start to test out some theories. And it's, it is kind of guess and check. So don't worry about that. It's going to take some time to find that. So that is kind of the work that we're going to be working on. Working on. Lots of works in one sentence. So again, as always, it's brand new stuff. It's difficult. Ask questions. It's okay to feel confused. It's okay to make mistakes. It's okay to feel a little frustrated, but don't let it get in the way to keep you from learning. Work by asking those questions, learn from those mistakes, keep that positive attitude. No, it isn't about having an answer right away, but it's about having that attitude towards how can I find a solution? Did this work? Oh, nope, I guess it's not my rule. Does this work? Yeah, it totally does. Cool, I found my rule, right? That's kind of what we're doing there. Anyway, as always, we appreciate you and we will see you next time.